Hassan's Maths channel. I'm now answering question number 5 from the May-June 2020 International A-Level. This is the Cambridge paper 4, which is a mechanics paper. This is paper 4 variant 1, and this is question number 5 here. And I've been asked to answer this question by one of my students. It says a child of mass 35 kilograms is swinging on a rope. The child is modeled as a particle P, and the rope is modeled as a light, inextensible string of length 4 meters. Initially, P is held at an angle of 45 degrees to the vertical, seen diagram. So obviously it's held at rest. Given that there is no resistance force, find the speed of P when it has traveled halfway along the circular arc from its initial position to its lowest point. So it's halfway along this arc to the point here where this length here and this length here are the same. All right, so we've got to find the speed when it reaches this point. Now its initial speed at this point here is 0. Its final speed at this point is what we have to find. Okay, and I'm guessing here we should take into account, we know the mass of the child is 35 kg. All right, we need to take into account the change in mechanical energy. Okay, and so we can see here that basically it starts off with 0 kinetic energy and maximum potential energy, gravitational energy, and it ends up at this point with the kinetic energy that we can find here. We need to consider, and if we consider this level as being a 0 level of potential energy for this part of the question, so I'm going to consider this as, just make that thinner. So this level I'm going to consider as the level of 0 kinetic energy, potential energy, sorry. Okay, so I'll say the gravitational potential energy here is equal to 0 at this level, right? So what we need to consider is the vertical height that it has moved through in going from the initial point to this point here. Okay, so we need to find that height there. That's one thing we need to find, right? And if we can work that out, then I think we can sort the problem out. Because what we're going to use here, we're going to use the principle of that the potential energy plus the kinetic energy at the start will equal the potential energy plus the kinetic energy at the end of this. So this is like the start and this is like the end. We consider this the end and we consider this level as the start. Okay, so what we can do here is we can say, okay, the potential energy at the start is going to be mgh. So we need to find what this h is. Okay, if we can find that, and the kinetic energy at the start, of course, is going to be 0. So we put plus 0. Okay, so this is like mgh plus, and this is going to be 0. And the potential energy at the end is going to be 0 because it's reached what we've defined as 0 potential energy for this part of the question. And the kinetic energy is going to be a half times m times v squared. Right, so basically the m's can cancel out. You don't have to worry about the m's. So we're going to have gh equals a half v squared. So we can now say that 2 times gh equals v squared. So v is going to be 2 times gh square rooted. Now we know g is equal to 10. So v is going to be the square root of 20h. So we have to find what h is. That's all. If I find what h is, I have answered this question. So I've got to find what this height is over here. And what I'm going to do is I'm going to consider this side of this kind of triangular shape. I'm going to consider this side. So I'll consider that length. Okay. I know that this is my height. This is what I'm looking for. Okay, the difference between this length and this length here. So if I consider this triangle here, and the other triangle I'm going to consider is one, if I join this point to this point here, okay, so we can consider that this is halfway along this arc. So this angle here is going to be 22.5, and this angle here is also going to be 22.5. This angle has been bisected, so this becomes 22.5. So we have two triangles we can consider. Okay, I can find using this big triangle. Here we have a right angle, and here we have a right angle. So we have this tall triangle here, which this one over here, right? We can find this side of this triangle. Let me just use these. I can find that length, okay, which is the length of this side of this triangle here. Okay, so it's this side of the triangle. Let's call that x1. And we can also take this other triangle, this 45 degrees triangle, and we can work out this length over there, between there and there. We can call that x2. And I can see that my height that I'm looking for is x1 minus x2. x1 minus x2. So if I find the length of this side of this triangle here and take away the side of this triangle here, I'll be left with h. So for x1, we're going to use this long triangle where the angle here is 22.5. This is 4 meters, and this is x1. This is a right angle triangle. So we can say that x1 is going to be, we can see that the cosine of 22.5 is x1 over 4. Okay, so we can say from here cosine of 22.5 is x1 over 4. So x1 is equal to 4 times cosine of 22.5. And if we consider the other triangle, where this is 90 degrees and this is 45 degrees, okay, and this is 4, we want to find x2. We can also use the same method, okay, or we could even use, for example, here we can use Pythagoras, because if this is 45 and this is 90, this is also x2, the same length, okay, because it's isosceles. When that's 45, it is an isosceles triangle. So we can say x2 is equal to the square root of, you can say, well, we can say 2. We can say is this actually, we can say x2 squared plus another x2 squared equals 4 squared. So 2x2 squared equals 16. So x2 squared equals 8. So x equals the square root of 8. x2 equals square root of 8. So x2 is equal to 2 root 2. So we can say here that x2 is equal to 2 root 2. So therefore h is equal to x1, which is 4 times cosine of 22.5 minus 2 root 2. Okay, this is 420 times, this length here is 4 times cosine 22.5, and this length is 2 root 2. So that is our height of our, that's the value of h, the height that the vertical height that this has fallen. So we can say that the velocity therefore is going to be the square root of 20 times, and as we said, it's 4 times cosine 22.5 minus 2 root 2. Okay, I could put, instead of 2 root 2, minus, 4 times cosine of 45. Okay, 4 times cosine of 45, which gives you 2 root 2, because we know that cosine 45 is root 2 over 2. You get 2 root 2 anyway. So whichever way you do, you get the same thing. So here we have the velocity, which we can then use our calculator to calculate. Okay, so we have the square root of 20 minus, or 20 times, 4 times cosine 22.5 minus 2 times the square root of 2, close that bracket, and that gives us 4.16435. So V equals 4.16, what was it? 425? 435. So we stop here. So we're going to have the velocity is equal to 4.16 meters per second. That's the velocity when it reaches halfway down, okay, this arc basically. All right, so there's the answer to part A. Now for part B. Part B says it is given instead that there is a resistive force or resistance force. The work done against the resistance force as P travels from its initial position to its lowest point is xj. So now it's gone down to its lowest position. The speed at the lowest point is 4 meters per second. Of course, the speed at the initial point was 0 meters per second. Okay. And now it's gone down to its lowest point. So we've just worked out what this distance was over here. We've just worked out what this distance is from here to there. That was 2 root 2. Okay, 2 times root 2. That was like the height. Well, that was that was basically the distance. No, sorry. What am I talking about? 2 root 2 was from. Let me just explain that again. We have this distance is 2 root 2. Sorry, this distance was 2 root 2. Okay, what we have to work out now is the total height that it has gone down. Okay, which is basically going to be twice what we worked out before. But anyway, we can just work it out anyway. We know that the total height here is 4. From there to there is 4. So this is going to be 4 minus 2 root 2. That's 4 minus 2 root 2. Okay, that's for the radius, and that's 2 root 2 from there to there. Okay, as we worked out earlier. So this is 4 minus 2 root 2. So in this case, in this question, that's our h. Our h in this case is 4 minus 2 root 2. Okay, so we know there's a resistance force this time. So now when you set up your equation, you have the initial kinetic energy at the start plus the initial potential energy at the start again. Okay, now there's no force in, there's no other force in, there's no force pushing it. So that's going to be everything we write on this side. But on this side, we have the kinetic energy at the end plus the potential energy at the end plus the work the work that left the system. All right, we always put that on this side. This is going to be, the work out is going to be equal to x, okay, which is the work done against the resistive force. That's equal to x joules. So that's what we have to find, basically. So if we think about the start, the kinetic energy is 0 because it's released from rest. And the potential energy at the start is mgh. So you got the mass, which was 35, times g, which is 10, times h, which is 4 minus 2 root 2. That's the potential energy at the start. And that's equal to the kinetic energy at the end, which is a half times m, which is 35, times v squared, which is 4 squared. That's the velocity which is moving when it's reached the bottom point, as we were told. And the potential energy at the end is 0 because it's got to, we're going to consider in this case, this as our 0 potential energy level. We should always make that clear. That's where potential energy is 0 in this part of the question for us. Okay, and plus the work out, which is x. This is what we have to find. So you can see we got everything we need. This is like 350 times 4 minus 2 root 2 minus, and this is a half times 16, 8 times 35 is equal to x. So that should give us our value of x. So let's see what we get. We have 350 times 4 minus 2 root 2. And then we got minus 8 times 35. Okay, and that should be our answer. Half times 16, yeah, that's right. So that gives us 130.0505, 130.0505. So our x to 3SF is 130 joules. Okay, there's the answer. Okay, so it says x joules, so we can say x is 130. We don't have to put the joules because that's already part of the step. So x is equal to 130. Okay, x is equal to 130. And there we have the answer to part B, which concludes this question on work, energy, power question. Right, this is about work and energy. So this is a very important equation here. And we have here also, if there was some other force that was pushing this along, that would be called work in. On this side, work in, that side, work out. This equation really helps you with all types of questions. Initial kinetic energy plus potential energy plus any work that went into the system will always be equal to the kinetic energy at the end plus the potential energy at the end plus any work that came out of the system, which is frictional forces, resistance forces, and so on. This equation helps you to make everything easy in sorting out your understanding, and it makes the calculations very easy for you to carry out. So in this question, we had a bit of geometry or trigonometry to deal with to find the heights or the distance through which the object fell vertically. Okay, remember it's always a vertical height, not the actual distance, like the displacement vertically that we consider when we do MGH, not the actual ground it covers. All right, so there's the answer to that question. I hope that was clear. Other questions from this paper will be found in the playlist, which should appear at the top right of this, at the end of the video. Other questions from this topic of work, energy, and power you'll find in the playlists for my P1 collection, for my M1 collection of Cambridge over here. You can subscribe to my channel by clicking on this link, and the video here will tell you how to use my channel to find things that you might be looking for. Thank you for watching, and see you soon.